Let's take a look at some of the questions on homework number 26, starting first with adding and subtracting polynomials. Now you can only add together like terms in a polynomial. So if the variables do not have matching exponents, they cannot be added together. So let's take a look at this first question here. So in this question we'll be subtracting, and that means that we're going to take this minus sign here and add the opposite, or distribute that negative sign to each of those items here in each of these terms. So that's going to be negative 7x squared, it's going to be negative 5x, it's going to be a positive 8. And that's what we're going to add to the first polynomial. Now you can add in any order that you want as long as the terms are like terms. So because this first term is an x with a power of 1, but this first term is an x to the power of 2, and they are unlike, they are not alike, and I'm going to write this term first because that has the highest degree. So that should be first, and then this term will combine with that term here. So 10x's take away 5x's is positive 5x's, and then plus 10 and plus 8 makes plus 18. So negative 7x squared plus 5x plus 18. You can use your shift 6, or you can use this keyboard here to write an exponent. So 7x squared, whoops. And then what did we have? Plus 5x plus 18. So again, like terms with like terms. All right, for this question here, we're adding, so we don't need to distribute a negative sign. We're simply going to combine like terms. So negative 4x squared and negative 6x squared is negative 10x squared. And then I have plus 4x, but nothing with an x in the other term. So that's going to remain the same, plus 4x. And then minus 8 and no constants in the first polynomial, so that's going to remain the same. All right, again, my highest degree here is x squared. There's nothing to combine it with, so this one will remain the same. 4 is a constant, but this one has a degree of 1, so that goes second, negative 9x. And then plus 4 with minus 6 is minus 2. Again, if you need to subtract, then you're going to distribute that negative sign here. So let's take a quick screenshot. Let's take a look at this one. When I rewrite it here, I'm going to get negative 4x squared, I'm going to get negative 5x, I'm going to get positive 9. And all of that is going to combine with my first polynomial, which does not change at all. These two are like terms. These two are like terms. And these two are like terms. So 6x squared minus 12x plus 16. All right, let's take a look at the next one, which is multiplying binomials. 3x plus 3 times 3x plus 8. And when I multiply these binomials, I'm simply going to double distribute here, or FOIL if you like that acronym, first times first. Don't forget you multiply coefficients, but you add exponents. Outside times outside, or double distribute. Sometimes after you're done double distributing here, moving on to my second term, right, inside times inside, and last times last, sometimes when you're done, the middle terms will be like terms, right? 9x squared plus 24x plus 9x, these both are just x's. So I can combine those terms together to get a trinomial. That's why it says express as a trinomial, as a hint. 9x squared plus 33x plus 24. Whoa, yikes. I think I got that right. All right, one more time. X plus 6 times 2x plus 8. I'm going to put that in here. And I double distribute here. First times first, out times out, outside times outside, inside times inside, last times last. Whoops, 42. All the middle terms are alike, so 2x squared plus 20x plus 42. Okay, you're going to type that in, and that's how you do it. So the next one asks you to square a binomial, and there is a shortcut to this if you'd like to use it, but it might not be what you think it is, and that is you can't just distribute this squared sign and think you square x and you square 11 and you're done, because you're not, because technically x minus 11 squared means x minus 11 times x minus 11. Double distribute here. And because our binomials are repeats, we're actually always going to get a duplicate here in the middle. We're always going to get two exactly the same terms. So we can combine those together, and then we can actually notice that since we're always going to get a double or a repeat of this, then we can just multiply 11 times x and double it, right? 11x, and we double it. And we'll notice that the first term is being squared and the last term is being squared. So a shortcut you could use is, instead of expanding it out and writing it times this and double distributing, instead of doing that, you can square the first term and square the last term. They will always be positive. And then what you could do is find the product of the middle two terms and double it. So I'm going to double 2 times negative 11x, which is negative 22x. So x squared minus 22x, x squared minus 22x plus 121. So I'm going to try that shortcut again here with my next one. I'm going to square my first, that's x squared. I'm going to square my last, which is positive 25. And now, in the middle, I'm just going to multiply these two items together, 5x, but I'm going to double it. So positive 5, positive x, that's positive 5x, so 5 times 2 is 10. So the middle term will be plus 10x. You square the first, you square the last, you find the product of the two, and you double it. So if you have a plus in the middle, you'll have a plus in your middle of your answer. So we're going to do this one more time without expanding it out by doubling the first, squaring the first, squaring the last, and doubling the product of the two. Alright, so let's take a look. We're going to square the first, we're going to square the last, and then we're going to find the product of the two, which is 10x, and double it to 20x. Because this is a plus, we will have a plus. X squared plus 20x plus 100. Alright, now we're going to do some arithmetic here with our polynomials. And just read carefully what they want you to do with each of these polynomials. They want you to find the sum of a single b, so w plus 10. They want you to add that to two c's. So we're going to put parentheses around c because we need to double it. So w plus 10, and now we distribute. Minus 2w minus 2. Combine like terms. Minus 1w plus 8. Or minus w plus 8. So when you do the arithmetic here, make sure that you're reading carefully if you need to double a polynomial, or in this case, triple a polynomial. But you shouldn't have any troubles with this. Alright, moving on to multiplying and dividing radical expressions. So if you find the product of a radical expression, then you are multiplying the coefficients on the outside. So let's see what we've got here. 6 and 3. And we would multiply radicands if we had more than one, but we don't. So now we're going to try and simplify this by looking for two factors that multiply to 54, with one of them being a perfect square, like this. So 18 times the square root of 9 times the square root of 6 is the same as 18 times 3 times the square root of 6. Let's see, it's 24, 54 square roots of 6. 54 square roots of 6, right? 4, 2, carry the 1, yes. 54 square roots of 6. So we're going to type that, 54 square root 6. Let's try this one more time. For this one here, I do have two radical signs. So if you have two radical signs, you can simplify it to one giant radical sign like this. 1215 divided by 5. So let's do that first. So let's see what 1215 divided by 5 is. If it's an integer, which is fantastic, then we can just try and find the square root of 243. And if I take the square root of 243 and it is not an integer, then I have to find, like this is not an integer, I have to find a product of two numbers instead. So I'm going to just start, let's see, 243 divided by 12 squared. I know this isn't going to work, but I'm just going to try it anyways just to show you. 243 divided by 11 squared. Nope, 243. I know 100 doesn't work, so let's go with 9 squared. 81. Oh, there we go. So 243 is the same as square root of 9, square root of 81 times the square root of 3. Square root of 81 is 9. Square root of 3 cannot be computed. So this entire fraction can be simplified to 9 square roots of 3. Let's try another one. What is the product of 10 and 696 radicand 96? So let's see. Okay, so we have 10 times 6 is 60. Square root of 96 can be rewritten. And so I'm looking for perfect squares that go into 96. Let's try 49. 7 times 7, nope. 96 divided by 7, 6 times 6, nope. 96 divided by, I know 5 doesn't go into it. How about 16? Oh, so 16 times 6, or 16 by itself, because the square root of 16 is 4. So 60 times 4 is 240, and the square root of 6 remains. 240 square roots of 6. Now remember, when you have a division problem like this, if they both have radical signs, then they can be simplified. This can be turned into a giant radicand. But something like this cannot. See that? They don't both have a radical sign. So I actually cannot divide these. But since these both have a radical sign, I can divide them. I can divide them. So let me erase this here. That is not the problem that we have. So the square root of 24 divided by 8 is the square root of 3. The square root of 3 actually cannot be simplified. So we'll just leave it like that, square root of 3. Here's what I meant. Okay, so these both have radical signs, so I can actually divide 672 divided by 6. I get 112. So then I start looking for perfect squares that can go into 112. No, 112 divided by 49. I don't think that works. I should have started a little bit higher. So I did 7, I did 6. I know 5 doesn't work. Let's try 4. Ooh, 112 is 16 times 7. So, right, square root of 112 is the square root of 16 times the square root of 7, or 4 square roots of 7. 4 square roots of 7. And that's because they both had radical signs. If they didn't both have radical signs, then I wouldn't be able to divide them. Alright, let's try adding and subtracting some radical numbers here. you cannot add or subtract if the radicands don't match. They have to match. So I need to simplify this. Let's see, I could make it square root of 4 times 3. Square root of 4 can come out, that's 2. Square root of 3 remains. But now I have matching radicands. So 2 square roots of 3 minus 1 square root of 3 is negative 3 square roots of 3. Pause it if you need to take a look at that for a bit longer. Negative 3 square roots of 3. Right, so if they don't match, you have to make them match. So here we go. Let's try this one more time. So right now I have 8 square roots of 5 plus 10 square roots of 20. This one needs to be simplified. So 8 square roots of 5 plus 10, 5 times 4. 4 is a perfect square, so it's going to come out as a 2. And you multiply. If you come out as a 2, you multiply by whatever is out there. So that's 8 square roots of 5 plus 20 square roots of 5. Or 28 square roots of 5. 28 square roots of 5. Remember, when you square root a number, it multiplies by anything that's already outside. Let's take a look at rationalizing a denominator. So denominators cannot have radical signs in them. Numerators, yes. Denominators, no. So the fastest way to get rid of one is to just times it by itself. Square root of 12 times square root of 12 is the square root of 144, which is perfect. So, because these two square roots, when times by yourself, you're squaring. So technically, right, these are inverses. So that's why I chose to times it by itself. Now, 2 square roots of 12 will remain on the top. These two cannot be combined because one is under a radical sign and one is not. I can try and simplify that 12 though. So I'm going to say 12 is the square root of 4 times the square root of 3. And the square root of 4 is 2. So I'm going to make that 2 come out and join a 2 that's already there. And this 12 is gone because I split it into 4 and 3. And now I can concentrate on my coefficients, right? 3 and 12 cannot do math with each other, but 4 and 12 can. So I'm going to have 1/3. So I can write it like that. I can write it like this, or I can write it with the 1 invisible. But these 3's cannot be combined at all. So the square root of 3 over 3. Oops, backspace, get out of the radicand. There we go. All right, let's try rationalizing the denominator one more time. Remember, the denominator cannot have a square root sign, but the numerator can. So let's see. I'm going to multiply by the square root of 63 because that will get that out free from the radicand. So 2 square roots of 63. I'm going to break this up into 9 and 7. Square root of 9 times the square root of 7. Square root of 9 is 3, so 3 is going to come out and join this 2. That makes it a 6. And 6 and 63 do not have any common factors, or do they? I feel like 3. I feel like 3 can go into it. You know what? I'm not sure, so I'm just going to use my calculator because it's late and I don't want to make a mistake. I'm pretty sure 3 can go into these, and I'm going to let the calculator reduce it for me. Look at that. 2 over 21. So 2 square roots of 7 over 21. Now remember, these two cannot do math. They don't do math with each other because one is under a radicand and one is not. 2 square roots of 7 over 21. Oops. And that's how you rationalize a denominator. Let's try the sum or product. Find the sum of 4 square roots of 2 and 2 square roots of 8. Also determine if the answer is rational or irrational. So let's see. We've got 4 square roots of 2, and we want to find the sum. And these cannot be combined because they don't have matching radicands. So let's see if we can't figure this out. 4 times 2, right? Square root of 4 is 2. That 2 is going to come out and join that 2 that's already there. This 2 will remain. And now I have completely matching terms, but I have matching radicands. And once you get them to match, they stay that way. 8 square roots of 2. Now, 8 square roots of 2 is irrational because the square root of 2 is irrational. And it cannot be written as a ratio of 2 integers, and it does not terminate or repeat. Let's try this next one. Find the sum of 3 square roots of 3 and the square root of 2. You actually cannot simplify those, so the answer is 3 square roots 3 plus square root of 2. It actually cannot be simplified any further. And that is definitely irrational because both of those numbers cannot be written as a ratio of 2 integers, and they do not terminate or repeat. So find the sum of 3 square roots of 3 and 3 square roots of 12. Okay, 3 square roots of 3 and 3 square roots of 12. Let me see if I have that right. Yep. This one we're going to break up into 4 and 3. This will come out as a 2. That'll give me 6 square roots of 3 and 3 square roots of 3. And that gives me 9 square roots of 3. Now the square root of 3 is not a perfect square. So that's why our answer will be irrational. It's irrational because it cannot be written as a decimal, a ratio of 2 integers, and it does not have a decimal that repeats or terminates. All right, good luck.